All right.
Hi, Ava.
Hi, Ava. All right.
So, is anybody gonna see Ava and can give her the study packet, or I could send her over?
I'll see her on, actually, not over the weekend. She's
Okay,
gonna be in
so-
Georgetown, yeah.
I hope I remember to email her one. So, this packet you should find very helpful. We're gonna go over some of the problems together. The good thing is most of these problems have, answers to them. I haven't created the test yet, but I would expect that I would have some multiple choice and short answer. We'll have no graphing on it. I think Miss Arcan's, test for her pre-calc class actually went back to some graphing of asymptotes, but I heard him talking about, a lot of the stuff that we had already done. So ours will just be on adding, subtracting, reducing, multiplying, solving. After we review today from this packet, which I created this morning, I really just found some things some other people have put out there. I'll let you know if this packet and Delta Math is sufficient to study. If it's not, I'll make sure I provide you more stuff or call to mind some worksheets that we've done together. But I'm thinking right now this packet's gonna be enough. If you get tripped up by some stuff in the packet, you might want to study your notes from class or, and I'm not saying this is the only thing you should study, but it's a good study guide of what I would ask on the test. The good thing about it is it also gives you some instruction in case you're good at reading, like out of a math textbook. It shows you what to do. There is going to be a part where they work it exactly like I do, where when we're solving and I multiply both sides by something to make it collapse really fast into an easy math question. And they do it the same way I do, but to read it, it looks very much longer and intense, and we'll talk about that, okay? There will be no factoring per se, but obviously you're gonna need to factor to be able to work these problems. You're not gonna need any problems that go factor x squared minus 5x plus 4, but x squared minus 5x plus 4 could easily be embedded in a problem that needs to reduce, all right? So, let's look at example 1. Let's just start with these examples on the first page. So even though this will be kind of boring, I'm sure you'll appreciate just like a really good solid review. And then we'll start one of my favorite topics next Thursday. Test will be Tuesday. All right, so we have x minus 2 over x squared minus 4. I haven't made out the test yet, but I would expect maybe some sort of bonus like I like to give you that has some critical thinking that pulls everything about rational functions together. Like if you graph this, let's talk about some of that. Would it have some asymptotes?
Yeah.
And you always want to be aware of the big picture anyway. And to me, it always helps me graph. It helps me know how many zeros I have and stuff like that. Yes. Anybody want to name, does it have horizontal asymptote?
No. It's bottom heavy.
Great.
I
And
don't
so
remember
it
that.
does. It's
Okay.
y equals, in the end, it'll go toward y equals 0 if it's bottom heavy. This one has a horizontal asymptote because it's heavier on the bottom. So this graph will gravitate towards 0 as we go out because the bottom's going to grow faster than the top. Is it going to have a vertical asymptote?
Yeah.
Yes.
1 or 2?
2.
Appears to have 2.
So negative 2 and positive 2.
Right, Nazareth. So negative 2 and positive 2, but maybe not.
But now can only be negative 2 because when you plug in positive 2, then it makes the top 0.
So now we think there's a what at 2? A hole at 2. But is that okay, me, as there's a hole at 2 if it cancels out? Yeah. There's some other things that it could be that I think one day even stopped and showed you, like absolute value of x over x or something, but it doesn't have to be a hole in the graph. It can jump or do something else, but that in your experience right now, that's what you've seen. All of that is going to help me like check my answers. Another thing, as you go forward, as you're sitting in pre-calculus headed to calculus, instead of dealing with this more complicated function, you can actually do your calculus, your derivatives that you'll learn, your integrals and stuff like that. You could even graph using this teeny tiny one instead of the bigger one. Except for you got to be aware that they're exactly the same. This was bonus from the last test, except how. They're exactly the same.
Except holding the graph.
Right. So you could graph this one, Bren, pretty fast, okay? But you've got to know that the original one you're graphing would look
There's a
just
hole in the
like
graph
it,
at
but
2.
you'd have to put the hole in the graph at 2, at positive 2. okay?
May I go to the bathroom?
Yeah, so, and well, as long as I've gone that far, the hole in the graph is where it canceled out, as y'all help me with all of this. The hole in the graph is at +2, and if I keep filling 2 into this, I'll get 0 over 0. But if I fill 2 into this, I get 1/4. And so I know the hole is at 2 1/4. So that's the good thing about this leftover part that you've reduced. Okay, now having said all of that, we've actually worked the problem, okay? So now we're just reducing. And I think we're fine with that. I'm gonna skip the next one. All right, let's go. These are all for you to look at. Let's see. Now let's go to the second page where we're multiplying, which is what you have for homework. Okay, so you're multiplying polynomials, and you're multiplying x plus 2 over x squared minus 9 times x minus 3 over x squared minus 4. If you're multiplying, you really just have the numerator and the denominator. Like, are y'all okay if I'm multiplying, that just really is one big fraction like that, okay? So if I have 1/2 times 1/3, that's just 1/6. You just multiply the numerators and the denominators. Multiplying fractions is easier than adding them because it does not require a common denominator. Now, I wouldn't actually FOIL these out though. That's kind of a skill that you're learning right now that I hope you carry with you. Definitely to calculus and also to standardized test taking skills. I've shown you some things like that as you head toward important SATs and ACTs coming up. I don't want to FOIL all of that out, which is our instinct. We feel like from our previous training, we just start distributing. But wouldn't it be better to factor it instead of multiply it out? If I multiply it all out, then I'm just gonna have to what? I'm just gonna have to refactor, all right? So instead of FOILing all of that, on the top I have x plus 2, x minus 3. Right here, I have x plus 3, x minus 3. And right here, I have x plus 2, x minus 2.
When you multiply, you don't have to like multiply the numerator by the common denominator, do you?
Not when you're multiplying.
Okay.
Multiplying does not require a common denominator, okay? The x minus 3's cancel, and the x plus 2's cancel, and you can see the answer here on your sheet. If it's an open-ended question, you can just leave it like this. If it all cancels, isn't there a 1 left on the top? Are y'all with me on the second page? And you can leave it as 1 over x plus 3, x minus 2, or if it's multiple choice, you might have to FOIL out the bottom when you're finished. Is that okay with everybody? Let's go in and do the next one, division. Instead of dividing by a fraction, you can multiply by its reciprocal. So I have, y'all are all looking at it, well, I'll write it down. X squared minus 5x minus 6 over x squared minus 2x minus 3. And instead of divided by, I'm going to go times x squared minus 9 over 2x squared minus 11x minus 6. That makes sense to everybody? Everybody see what I just did? So on your test, on the divided by ones, like, be aware of them and make sure you flip over the second part. Y'all think all of y'all learned something I did not hear when I was in middle school, is that keep, change, flip, or something like that. So you keep the front one, you flip the back one. I think I've shown you just once why that makes sense. That always used to bother me. I didn't like math rules I didn't understand. You may or may not care, but whether you understand it or not. But it's nice to see. I think we talked about something like this the other day. So if I say 10 divided by 1/2, what does that turn into? It looks like it should be smaller, like 5 or something.
Oh, 10 times 2?
It's 20. It's 10 times 2 over 1. Instead of dividing by that fraction, you multiply by the reciprocal, and this is 20. But this is like if you had 10 candy bars and you cut them all in half. You divided them into halves, you would have 20 pieces. So that's why that works. All right, so now I'm going to start factoring, which is just sort of up to you. You can do it in a new step or just do it above and below it. So that I'm really clear, x minus, 2 and 3 is not going to work. So we'll talk about factoring, which we spent a lot of time on. At first I saw 2 and 3 because of the 5 in the middle. I love this kind of factoring where there's only a coefficient of 1 in the front because I can do it in my head. 2 and 3, I can't make it work. Why not? Okay,
Because if
Alex?
you do the two negatives, you get a positive, and then it doesn't really work because you'll never get 5.
Right, so at first I thought I could get a -5, but if I have a -2 and a -3, Alex is saying it would give me a +6 on the end. So I decided to use 6 and 1, and the 6 would need to be minus and the 1 would need to be positive. Just stop me if you have a question about my factoring. Alright, the next one is the difference of squares. Your math teachers always say that word, x plus 3, x minus 3. This one would be a 3 and a 1, x times x, 3, 1, minus, plus. And now we tackle this thing that none of us really like as much as the ones that start with 1x squared. But first rule of factoring, take out what's in common. I don't see anything in common, but you definitely want to do that and keep up with it, by the way. If you factor out a 2 or an x or something, keep up with it on the bottom or the top. Also, like Kate brought up last class, we could do b squared minus 4ac. If we're getting frustrated with it, there's a chance maybe it doesn't factor. And if we get a perfect square, it tells us it does factor. We went over that last class. So now here I go with my trial and error. I factor the front and then I factor the back. After I get those factored, I start to play around with it till I get the right signs and the right numbers. So 2x squared, I'm going to put 2x and x. I think with that 11 in the middle, I'm going to need a 1 and a 6. So a lot of you are already getting where you could kind of see ahead. Do you see my putting the 6 over here with my 2 smiles? That gives you outside and inside. I get a 12 and a 1. If I didn't, I could just switch them. I want it to be minus 12 and positive 1. Okay? X minus 6 cancels out. X plus 1 cancels out. X minus 3 cancels out.
It's so nice when they cancel out.
Oh, it's so much fun. It's so
satisfying to see them all crossed out.
But they all cross out as a 1-to-1 ratio. Some people write down 0, but that would be 1. So you can see your answer on the sheet there, okay? Again, in your study, and if you get confused, I think this sheet just really is got nice, sweet examples, not too easy, to where, you're like, oh, well, thanks for the easy examples, but now what do I do? So now we're into adding. Adding and subtracting fractions is more difficult than multiplying and dividing because it does require a common denominator, okay? So next example, I'm on the one that says add and subtraction. And y'all see the one that has x minus 1 over x squared minus 4?
Yeah.
To save time, I'm going to factor as I go. Plus so this would be your first step. This one I can hit with a 2 and a 3, can I? Alex, you were explaining the last one. This one, if you look at your papers, x squared minus 5x positive 6. So is everybody okay with my factors? Notice the plus sign. And so now I need a common denominator. And this is of the caliber that I put on your quiz, where of like Delta Math didn't have a whole lot of these that were a little bit harder. Because, by the way, remember I talked about the plus and the minus signs are like super glue. So if x happened to be something like 7, we don't know what x is right now. But if x was 7, that would be 9, and that would be 5, and that would be 4. So you would have on the bottom a 7, a 5, and a 4, and you see how those would interact to give you your common denominator. Okay? So these are 3 different numbers happening. What does this one mean?
X minus 3.
Alright, x minus 3 and x minus 3. Alright, are y'all okay with that?
Yeah.
And what does this one mean?
X plus 2.
Yeah, just take your time on these. X plus 2. I'm going to leave the bottom factored. Remember that when you get into calculus, when you've got a really long derivative that you're working on. You might hear some of your friends talking about that are seniors. You have a real long derivative you're working on. Why am I not going to multiply that out yet? Because I kind of wonder if something might cancel later. And if I do all that FOIL, I'm going to have some big ugly x cubed thing that even I would have a hard time factoring. Again, a good standardized test taking skill. When you're adding, you are going to need to go on and see what's on the top by multiplying it out because you have to add like terms. So up here I have x squared minus x minus 3x plus 3. Be really careful if that's a minus sign because it needs to be distributed to everything behind it. Maybe it's a good idea to do that to the whole back part. That's x squared plus 2x plus 2x plus 4. Alright, so now I have 2x squared. Alright, so I did this, 2x squared. Negative 4x and positive 4x is gone. And I have 7 over all of this.
Wait, negative 4x?
This is negative x and negative 3x.
Oh, okay. I see.
So that's negative 4x and positive 4x. And so a whole lot quicker, I got the answer. Did y'all see that took them a page?
Yeah.
But they're explaining it to you as they go. Okay, I think I did 3 steps, maybe two or 3 steps. Now, why is 2x squared plus 7 not able to factor? You can never factor what we call a sum of squares. Do y'all see why I'm calling that a sum of squares? You can factor a sum of cubes, but you can't factor a sum of squares. I like to really understand what I'm doing, like I started class earlier today with talking about the asymptotes. 2x squared plus 7, only talking about the top of this. Okay? Why am I not going to factor it? 2x squared plus 7 is like an x squared graph that's stretched, and then where is it moved? What does the plus 7 do to this picture? No, y'all both did the wrong way. It goes up, okay? So is it ever gonna have any zeros? Is it ever gonna have any solutions? Okay, anyway, that's kind of almost beside the point. You would not be able to factor this. If you wanted to just, try b squared minus 4ac, it's kind of a good lesson here. What's b on the top? Yeah,
0x.
So it would be, so it'd be b squared minus 4ac.
That always confuses me. Are you multiplying the 4 times the a or the a times the c times 4?
I will go back to that in just a minute. But in any way, do you see you're going to get a negative under the square root? No, you're wasting your time on that. All right. It gets confusing. The more math you know, all of a sudden the easy math is hard because now your critical thinking skills are so much better. And I always have to stop and talk about that. Like if I had this as opposed to this, then people get confused because we've taught you to distribute that. So that's 4 times 2 is 8, and 4 times 3 is 12. That's 20. And I can verify it because that's definitely 4 times 5, right? Okay. Up here, Kate, you can do the 4 times the 2 and get 8 times 3 is 24. Or not just Kate, everybody else. You could do the 4 times the 3 is 12. Times 2 is 24.
Yeah.
You could do the 2 times the 3, so don't distribute that 4.
So you can kind of just do anything.
Yes.
Okay.
So a lot of times if I have something like this, 5 times 3 times 2, I go 30, because I'm going 10 times 3.
Okay.
Like I know that 15 times 2 is also 30. But, so I don't know what I'm doing. And when I have that 4ac, I'm just doing whatever. You just got to mix and match and get it. But you could always just go this times this, that product times that.
Yeah, because I feel like the first instinct is with the parentheses.
Well, you could also put this in parentheses. It's just that we tend to go 4ac. Those are actually 3 numbers multiplied together, like 4ac.
Yeah.
But a lot of math teachers, when you see a variable, we just tend to put it in parentheses instead of a dot.
Okay.
In case it's negative. Okay, so hope y'all liked this boring day for review and the packet. I thought it was great. All right, now we're going to subtract. Subtraction, you should be, I don't want you to be scared. I want you to be on your toes though. Okay, when you see that minus sign, a whole lot of things could go wrong. Or one little mistake's going to make all the numbers go wrong.
The subtraction sign doesn't affect the denominator, correct?
It does not. It's like having this, 5 over 7 minus 3 over 7. I had 5 sevenths, somebody took away 3 sevenths, and I have 2 sevenths, okay? Alright, 2x minus 1, I'm going to factor as I go, x plus 2, x plus 3, minus 7 over x minus 4, x plus 3. This minus sign, even I'm on my toes about this. I'm like, oh, let's be careful, okay? So now, what does this one need? Ooh, this is really ugly.
So I'm gonna have to write it smaller. 2x minus 1. On the bottom, I already have x plus 2 and x plus 3. This one's also gonna need an x minus 4, and you put it on the top and the bottom. Some of y'all noticed I wrote in your quizzes things like that, okay? If I put an x minus 4 on this, I've gotta put an x minus 4 on that. Then this one is minus, and this one also needs to be x plus 2, x minus 3, x plus 3, x minus 4. Alright, so what does this one need right here? What did I give it down here?
X plus 2.
X plus 2. So what I really did in this step is I put in an x plus 2 and an x plus 2 where there didn't used to be one before. So do y'all see this is not an equation? What's coming up soon when it's an equation, I could put something on both sides. When it's just a fraction there, or what we call an expression, I can't just multiply the top by something unless I do it to the bottom also. Okay, Aline, do you have a question?
What if you have like both x plus 3 and x plus 3 on one side? Do you like still?
You would need 2 of those. Is that what you're asking? Yeah, it's like having a 3 and a 9. Y'all see what she's saying? If I had if my denominators were 5/9 and 3/9, sorry, that's not what I'm saying, that's not what she's saying. If, our denominators
It's like x
were
plus 3 and
like
x
2/7 and minus 3/49. They both have a 7 in them, but that one doesn't have enough 7s in the front. Okay?
So you would just multiply only one side by 7? Like one of those fractions?
Yes, yeah. So her question was great. If this had 2x plus 3's in it, this one needs 2 also. Okay, now this minus sign is what I'm all keyed up about. I'm gonna leave this x plus 2, x plus 3, x minus 4. Alright, I'm gonna FOIL this out. Because there's a minus sign, I've gotta subtract all my like terms. That's why I'm FOILing it out. If it's multiplication or division, and there's a minus or plus sign between the two terms, do y'all see these two terms? If that was a dot or a division symbol, I wouldn't be doing the FOIL. I would keep all the little parentheses and see if something canceled. Right now I've got to
But
subtract
on the bottom,
top.
you keep all the.
I do, So this is 2x squared minus x minus 8x plus 4 minus 7x minus 14. Do y'all see how I distribute that minus sign to everything? Now Kate, to go back to Kate's question, and it really comes up here. Suppose you had blah, 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 and you had minus 7 times x minus 2 times x minus 3. And what in the world are we supposed to do with the minus sign, and what are we supposed to multiply together? It doesn't really matter. Like Bryn could multiply this and then distribute to 7x minus 3.
Mm-hmm.
Alina could do FOIL and then distribute her 7.
Negative
But-
7.
Right, and then you've got to run that negative all the way through, okay? I think I would tend to do this, whatever's in the front, blah, 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 minus 7 times x squared minus 5x plus 6. That's 6. And then I would have minus 7x squared plus 35x minus 42 in case that happens. Do y'all see what I mean?
Yeah.
Okay. All right, back to this one.
Towards the end of the class, can we take a few minutes just to do a couple study problems, like by ourselves, and like see if we need help?
Maybe we'll see how it goes. Alright, so this is 2x squared. This is minus 9x minus 7x is minus 16x minus 10. Alright, great. Look what just happened. Provided that I've done this right. I guess we could check the chain of events on our sheet. Good, that's what they have. What's your first rule in factoring?
Figure out what's in common.
Which is gonna make your life tons easier here than trying to figure out 2's and 10's and everything, okay girls? What did it have in common, Kate?
2 and,
Two.
no, just 2.
Just the 2, but whatever it has in common, you take it out. I don't know where my extend page is when I come in here. Because it doesn't, I'm gonna go to the next slide. Alright, so we had, 2x 2x squared minus 16x minus 10 over x plus 3, x plus 2, x minus 4. So we factored out, like Kate said, we factored out the 2. And now I can't factor x squared minus 8x plus 5. Sorry, minus 5. I can think of factors of 5 that give me an 8. The only reason, girls, that I can do that is because there's a 1 in the middle of that right now. If it said 2x squared minus 8x minus 5, I might should try to factor it because that 2 will interact. You could also do b squared minus 4ac with that. And nothing factors, so it's reduced as far as it can. This one's undefined at -3, -2, and 4. It'd be a really weird graph if I made you graph it. It would have 3 vertical asymptotes and a horizontal asymptote. Okay, so then you run into the next page, which kind of brings up what Bryn was asking, where you've got some practice problems that you can check your answers to.
Can we go over multiplication?
Hang on just a second, okay? Do y'all see what I mean? All right, so you have practice problems that you can do. Bryn, I've done a couple multiplications. You want me to do some more?
Yes, please.
Okay. So
Can we
let's
also
do,
do solving for
Can we
x?
do the
we're gonna do
like-
solving, yeah.
Yeah, that's one that I was thinking
So
about.
I'm watching the time for that, because that's the newest thing. Let's go to number 8. All right, so this is number 8. You're looking at it on your paper, on this paper with all the questions. I love this because the answers aren't right there for you to look at. You gotta turn the page to see the answers. And I think they give you the solutions too, or just the answers. Again, I didn't write this, but I thought it was so good I didn't write one. Okay. On 8, I have x plus y over x minus 1. Since it has times, I don't have to flip anything. I'm just going to start factoring with the times I'm going to factor. X minus 1, x minus 1. And the bottom, how do you factor x squared minus y squared? X squared, difference of squares, Kate. X
So
plus
x.
y, x
X
minus 1. Kind of weird, it's got that y in it, but, okay, great terminology, Kate, that's good. All right, these cancel. Oh, when it's times, I can just treat it all together like one big fraction.
Wait, so why are you multiplying by?
I'm not multiplying by anything, I just basically copied the problem down. The front part of it was x plus y over x
Oh,
minus
and this
1.
factors out into x times x minus 1.
Yeah, I just didn't write the problem down, I started into my first step. So x plus y's cancel, x minus 1's cancel, and the answer on the next page should be x minus 1 over x minus y. Before this year, and that is certainly not unique to this class, you see how much I stressed it because I was expecting this. I think before we really started this great year together, a lot of you would have then canceled out those x's and said the answer was like 1 over y. Girls, look, think back. Why am I not going to cancel out those x's?
Because they're not multiplied, like they're standing on.
It's an
themselves.
x minus 1, it's
Yeah.
not an x, right? Okay? That plus, those minus signs are glued, like this. If I had 5 minus 1 over 5 plus 1, let's make it 10 minus 1 over 10 plus 1. The temptation's there to factor out the 10s, but isn't that 9/11ths?
Yeah.
Does not reduce, okay? All right, so, now, so that's practice on adding, multiplying, subtracting, dividing. Watch out for your dividends, and lots of answers and solutions. Great study packet. Now let's go to solving. All right, so it starts out slowly. Let's go on to example 1, because we're doing so good on time, surprisingly. That didn't happen much in here. All right, so, example 1, I think it's good every now and then to go back and do an easy example because it helps me wrap my mind around what it is I'm doing. And by the way, when I got into upper level mathematics like calculus, and I still do, if somebody comes to me, like I'm tutoring somebody from another school and they come to me with a problem or email me a problem that I've never worked before and it's not part of my own lesson plan and I've already vetted it, I sometimes have to go, wow, how am I gonna work this really tough calculus or physics problem? And many times I dumb it down for myself, and I'll look at something, well, what do I do when it's easy? And then go back to what to do when the numbers are bigger, okay? So I think it's probably a good skill to have anyway. That yellow's kinda hard to see. I'm probably making it worse.
You do physics tutoring also?
Not if I can help it. Okay. But if you're doing calculus, it's hard to, like a physics teacher.
We're doing like kinematic equations right now.
Yeah.
It's very
those are
difficult.
not
It's
the
so
best
scary.
ones.
So
Yeah.
hard.
Mathematicians usually don't memorize this formula, so I do a lot better if I'm just deriving it with my calculus.
Yeah.
And because the formulas don't really mean anything to me. But I've never taken, I was just straight mathematics. I was like, I'm an academic mathematician, not an applied mathematician, even though I strongly believe in that. Okay, this goes back to Alina's question about the 9. This one has a 3, a 6, and a 4. I want the least least common LCD, is that what it used to be called, least common denominator? Okay, I mean, I could just slap all those numbers together, 3 times 6 times 4, and have a big number, and that would be fine. But wouldn't 12 take care of everybody?
Yeah.
Okay, the 6 has a 2 and a 3, and the 4 has a 2 and a 2, and so 12's gonna take care of it. Now, this is what, I still even talk to some other math teachers about this when I see their students actually getting the common denominator. Like, I could sit here and get the common denominator. In fact, don't write, just watch me do this today, okay? Like, if there's a reason not to write, because I'm gonna erase all of this in a minute. Some teachers go, let's get a common denominator. So I'm gonna multiply this by 4 and this by 4. That gives me 8x over 12. I've got to multiply this by 2 and this by 2. That gives me 10 over 12. I've got to multiply this by 3 and this by 3. That gives me 9 over 12. First thing I don't like about this method is I still got fractions, which I don't like. Like, seriously don't like them, okay? Second thing is I'm really going to be more prone to make mistakes the more I work with fractions. Let's keep on going. Wouldn't you add 10/12 to the other side? By the way, at this point, I always have students that stop me and go, can I reduce that? I'm like, sure, but then I would just go back where I came from. I don't want to do that, okay? A 19/12, and then maybe cross multiply. So that gives me 96x equals whatever 19 times 12 is, and then I would divide by 96, okay? As opposed to doing this. This is the luxury of an equation. I need to know the common denominator. I think a couple of people brought this up today. I need to know, doesn't it bother you when a teacher doesn't erase everything?
Yes.
In second grade, I can remember just sitting there looking at a little dot on the board and didn't have any idea what my teacher was saying. Yeah, I'm just like, please go erase that so I can pay attention. What was her name? She was so pretty. Okay, thank you. Okay, anyway, I need to know the common denominator, but with an equation, I don't have to get the common denominator. If I don't have that equal mark there, and all I'm doing is adding 2 fractions, I have no choice but to get the common denominator. With an equation, all of a sudden I have a seesaw, okay? So I have this balanced equation. Sorry, my sleeve gets, I'm really actually finally warm now. I've been able to take my jacket off all day. Has it been cold a lot of places y'all went?
That's freezing. It's
During the winter, it's either. I want my jacket.
I forgot my jacket at home.
Yes, exactly.
Down to 79.
67.
One of my friends called me today and they were in a panic. They're like, I can't find my winter clothes. I'm like, we all live in apartments. Like your winter clothes have to be somewhere in your
But if
apartment.
there's like storage in your basement.
They
I don't have that.
But I had on Halloween socks that were so cute Wednesday night. They're green with purple webs and black spiders. Wednesday night I got home from it, like, I know we were going to a thing, a dinner at someone's house that I know they, take your shoes off at the door, so I thought I got these really cute socks. So, isn't that horrible when you take your shoes off and you got like holes in your socks or your toenails aren't polished? Anyway,
Yeah.
so, I got home and I'm like, love these socks. I took them off and I went to sleep. And I cannot find them. I looked for like 2 hours yesterday. That's exaggerating, but I'm like, they're in my
Maybe
apartment.
they'll come back on Halloween.
Are they in the laundry?
Maybe the boogie dance.
I don't think I put them in the laundry.
I
And
must
I
have
lost
thought.
my,
I
I couldn't
always
find
have
my
my stuff in the
jack-o'-lantern
laundry.
socks either. I'm just like, I know.
Are they in like your husband's drawer?
Do you have any pets? Maybe a dog. Your dog
Maybe,
would like to
no,
take
I have
it.
cats. They don't,
Oh.
they don't take socks.
Yes.
Don't you get that feeling? Y'all have that, those of you that live in an
Yeah.
apartment, you're
Yeah.
like,
Yeah.
It's
I
one
always
time
lose
I
socks
lost
and then they
my
show up like
iPod.
3 weeks later.
I
Like,
have
oh,
my
it's
iPod-
bad.
my
Yeah.
iPod-
I
My
lost
iPod
my
Touch is probably
DSi
somewhere still in my apartment still.
Same with my
From-
my iPad from like 7th grade. My mom like took it away and hid it somewhere, and I've never seen it since.
She's probably forgotten where it is.
Yeah.
When I was, I'll show you a picture of it sometime, like we need to keep on reviewing. But, when I was about your age, a freak flood hit
At least I know.
central Mississippi. And the house I grew up in, what, 3 kids, like 2 parents, the 5-bedroom house, like in the like a house like in a normal
I can't
house.
believe you lived in Missouri. That's like so crazy to think
Mississippi.
about. Mississippi.
Which
I like
is
can't
even-
picture
Which is
it.
even crazier. Anyway, their house flooded, like, I came home from college, actually, my freshman year, while the house was flooding, and we were just like getting everything out of it, but what was so funny, because my family can always find something funny about things, but the water went up to like the root, like it ruined their house, and they had to start all over in many, many ways. So anyway, my sister and I'd be standing in the hall with people actually with boats in our house carrying pianos out. It was crazy. We're like, we gotta get this stuff out. Like, we're saving here. Like my parents' wedding pictures, and there's a couple of times like a pink brush flooded by, and we're like, dang, we don't even know where that was. Like, we lost that 4 years ago. There it goes. We don't know what it was behind. But yeah.
Do people like swim in the Mississippi River in Mississippi?
You can, well, actually, the Mississippi goes all the way like through the nation, so it's not just in Mississippi.
I'm aware of that.
So, I don't get in, I
Keep you from trading on
got
the
in rivers in
Mississippi
Mississippi, but I didn't never go to swim. When I lived in Tennessee, people aren't really gonna go swim in those rivers. They're usually gonna raft in them or boat in them. But I have been in a few rivers,
Is Mississippi
hiking.
on the water?
The southern part is. It got hit really hard by a couple of hurricanes.
Is it in the Gulf?
Just thinking about the people.
Yes, it's near New Orleans.
Yeah.
Think New Orleans, and that's southern Mississippi.
Yeah.
Biloxi. Okay, so now that we've had our geography lesson, back to this. Okay, so we have this seesaw, and we want to keep it balanced. And so if we put a weight on this side, we have to put the same weight on that side. But what's beautiful about it, and I really lost the momentum because of all of our different stories, which is very typical for me. And while I'm saying that, I'll tell you another story that some of you have heard before. When I'm like out somewhere meeting people and they're like, what do you do? And I'm like, first of all, they're like, the math that I teach. And the very fact, some of them get stuck on the fact I teach teenagers and like high school kids, and they're like, oh wow, isn't that scary? they think that you're so like judgmental and critical.
That's
and,
kind of
yeah.
true for
And
some.
sad.
That's like
Not
middle
us, but for
schoolers.
some.
Yeah,
Like
middle
7th
school.
graders are
Middle
so
school's
scary.
I was such a
So
brat.
mean.
But anyway, one question that I get many times is like, well, what do you do about discipline, especially in this day and age? And I'm like, I'm the biggest discipline problem in the room. Like, I don't ever have to worry. And y'all are all just sitting there going, okay, when's she gonna come back? Come back around. Okay, so back to this. Big deal. I just hit undo for this long thing that got really ugly. And I had fractions all the way until the very end. It's in my best interest to get rid of fractions as fast as I can. So to reiterate, when I'm adding, subtracting, multiplying, and dividing, I have no choice but to keep the numerator and the denominator. But when I have a seesaw, when I have an equation, I have the luxury of putting something on both sides instead of putting something in the top and bottom. Do y'all see what I mean? So I'm going to come on this side and put a 12, and I'm going to come on this side and put a 12. I do have to think up my common denominator, but I'm going to slap them on the seesaw. Then I'm going to carefully distribute, which can get confusing, okay? So when I distribute that, do y'all see that gives me an 8x? Are y'all okay with that?
Yeah.
Because what happened with the 3 and the 12? How many times does 3 go into 12? 4 times. Why am I not just canceling it out? Because
No,
don't I
4 times
also
2.
need the 12 over here?
Oh.
Okay, so I don't wanna cancel that because I also need it over here, so I'm doing it in my head. That gives me, 10. And what does this give me? 9. Don't you like that tons better? I mean, again, I lost all that momentum with all those stories, but if I hit undo, 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 you'd go, oh, I like this a lot better. All right, now you see they got, 19/8 like we're gonna get here for our answer when you add 10 and divide by 8. But notice all of their work compared to mine, okay? The reason is that they're gonna do this, which you might want to on test day. You might not want to do it in your head. You definitely want to put just 112 on this seesaw and 112 on that side of the seesaw. But instead of mentally doing it, you might want to physically see 12 distributed to 2x over 3, 12 distributed to 5 over 6, and 12 times 3/4.
So you
Do you see you might want to physically distribute that so you can actually then look at it, whereas I did it in my head. So you'll see your sheet does that. Now they're gonna get 8x minus 10 equals 9. So that's your decision, okay? Anya,
Oh,
were you saying so? Okay. Dakota?
Wait, so when you're, like, I'm just confused about the distributing. When you're distributing 12, why wouldn't you multiply, like, how does it just get rid of the denominator?
Okay, I don't want to, I like to reduce as I go. I like to make my life easy and make your life easy. So I have an option here, Dakota, to say 24x divided by 3, which does happen to be 8, okay? But I reduced it. Like, I'm thinking in my head, how many times does 3 go into 12?
Wait, so then,
How many times does 3 go into 12?
4, but
Times 2,
8,
8. And then when I go here, this is like 12 over 1.
yeah,
How many times does 6 go into 12?
2.
Times 5, 10.
So, I think I was just confused because, wait, so it's like you 20, okay, I think I see.
So I'm not gonna multiply it out, because those numbers might get really big. Like, for instance, if I have, 12 times 81x over 3. I'm not gonna say 12 times 81.
Yeah.
I'm gonna say 3 goes into 12 4 times, so I get 324. That's what I'm doing.
Can
Okay?
you just cut out the step here where you just like you don't have to multiply everything?
You
by
don't
12,
have
you can
to
just
put this step
multiply
in
it
there.
By like the,
You can go straight here if you're able.
okay.
Is that what you were asking?
I mean, not, it's fine.
Or no, go ahead.
Well, no, it's not really a question. You just keep going.
Alright, so, next one. I have, 5x plus 5 over x plus 2 equals 3x, plus 3x equals x squared over x plus 2. Now, isn't this technically over 1? Alright, now this one's not bad. What's my common denominator?
X plus 2.
X plus 2. So I'm gonna multiply this by x plus 2 and this by x plus 2. This equation symbol makes that a seesaw. Again, you can look at other places that actually take the time to add the left-hand side together and get a common denominator, which I never do. I don't like fractions, and mine are about to be gone, 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 okay? What happens there?
The x plus 2's cancel out.
So, Anya, we have 5x plus 5. Here,
It has to multiply.
I have to multiply 3x times x plus 2. And here, I get x squared. And then it's a longer problem than the last one we had, but, sorry. My fractions are gone. And now I have an algebra 1 problem. Alright, so I have 5x plus 5 plus 3x squared plus 6x equals x squared. I'm gonna get it equal to 0 and factor. 2x squared plus 11x plus 5 equals 0. Did y'all see that? I said 3x squared minus x squared, and then I added like terms together. I'm not gonna finish this one. They went ahead and factored and answered it. okay? So you would factor and answer it. Well, let's do that. Let's factor, because I do need to do it at least once. I don't know why this won't extend page. This is really weird. Oh, no, now it will. Alright, so this is 2x times x, 5 and 1, plus and plus. And remember, you want it to equal 0. So you set this one equal to 0 and this one equal to 0. Some people can do that in their head. If you can't, go off to the side like they probably did on your sheet here. Okay? But what makes this 0? Negative 1/2 and negative 5. So the last thing you need to check is look back at the original problem. What's the only number I could not let slip in here? Negative 2, Mia, great,
And
okay?
that's like a restriction.
It's a restriction, so if it pops up, you've got to cross it off. But these are both acceptable.
Why is negative 2? Because, plus 2.
Well, in your original problem, it would give you
Yeah.
0 on the bottom.
Yeah.
Okay. All right, so now, let's go to
I'm gonna throw out.
example 4. Or let me see. All right, let's go to, yeah, example 4 and 5 are pretty similar. So let's go to example 5. I'm going to example 5. And I've run out of sugar gliders. So we have a super boring slide. All right, so I have x minus 2 over x minus 3 minus x plus 2 over, x plus 2 equals 5 over 8. I don't like this problem. I wish
That's a
it said-
lot of common denominators.
I wish it just said x plus 3 or something. Oh, wait. X plus 2 over x plus 2, which is just 1. I don't know why they didn't just write down 1.
Oh gosh.
But let's pretend like that didn't, oh well, we're gonna go ahead and work it. Okay, so what can I put on both sides? What is my common denominator?
X minus 3 and x plus 2 plus 8.
And 8. So I need 8 times x minus 3 times x plus 2. Over here I need 8 times x minus 3 times x plus 2. Oh. Alright, so now I'm going to distribute. And if you could do it mentally, do y'all see the x minus 3's cancel?
Yeah.
So that gives me 8, an x plus 2, and an x minus 2. Because those x minus 3's canceled. Here, what's going to cancel?
X plus 2.
That x plus 2. So if you could read my writing, I would have an 8 and an x minus 3. And over here, I have 5 times x minus 3 times x plus 2.
Wait, Mrs. Ari,
Uh-huh.
I just have a question. Doesn't the 8 times x plus 2 times x minus 3 just go into 8x squared minus 8x minus 48? If you distribute it?
Well, then you won't be able to reduce. I would not want to do that. I want to cancel and get this nice.
So you want to keep that as the denominator for 8 times x plus 2?
As I
times x
distributed, do you see how I can see what cancels as
Yeah.
I go? Yeah, I don't want it to be a big
So
old.
you don't want it to be that. You want to keep it,
Once I get this nice little
okay.
thing without yeah, if you multiply it out, it's the same thing I've said many times. You're not going to see what cancels.
Okay.
I'm not sure I'm answering your question.
No, you are. Thank you.
Okay. Now, I think I don't have any choice but to multiply it out, right? Dakota?
Well, wouldn't you cancel out the x plus 2 that's next to the, or I guess that would be negative, well, right there, that's,
This?
right, yes.
This is all multiplied together.
So, no, but when you're, if you cancel out the x plus 2,
Yeah, these were gone. And I had an 8, an x minus 3, and then x plus 2 right here on the top. So see, you had this, and this was gone.
wait, because I'm looking at just the way that.
Okay, don't look at that.
Okay.
I'm gonna compare it to that one in a minute, but we're gonna all end up at the same place. So if we're not gonna compare it to that, do you know what I've done up here? I had 8 times x minus 3 times x plus 2, if you could still read what I had. Don't look there, okay? Do you see my common denominator?
Yeah.
All right, so I'm gonna multiply by 8, x plus 2, x minus 3. When you distribute this, do you see your x minus 3's cancel? You see that x minus 3 and that x minus 3? So what's left is an 8, an x plus 2, and an x minus 2. That's right here.
Okay.
Then I'm gonna distribute over this minus sign. And if you can still read my writing, I have 8, an x minus 3, and an x plus 2. This x plus 2 is gone. So I still have an 8, an x minus 3, and an x plus 2. That's right here. And then over here, the 8's gone. So I have 5, and x minus 3, x plus 2. So
So you have to distribute that out.
So like this, yes. So Dakota, if I have 7 over x minus 1 minus 5x plus 3 over x minus 3 equals 8 over 5. What's my common denominator?
It's gonna be 8 or 5 times x minus 1 times x minus 3.
So I'm going to do that to both sides. 5 times x minus 1 times x minus 3. So I just slapped it on both sides. Now I mentally distribute. You can physically distribute like they're doing on your paper, but look up here. What's going to cancel when I do all of this?
X minus 1.
Are you okay with that, Dakota?
Yeah.
The x minus 1 is going to cancel.
Yeah.
I'll have a 5, a 7, and an x minus 3. Now, when I do that,
Minus 3 cancels.
okay, so the x minus 3 cancels. On top, I still have a 5x plus 3. The x minus 3 cancels, so I have a 5 and an x minus 1. And over here, I have all of that on the other side. My point is, that's a pretty easy equation to work with,
Yeah.
if you can keep up with what you're doing, okay? It's worth it to, but I always go slowly through my distributing of this nasty mess that just got up there. I go really slowly. In fact, you may want to take time to write this one next to that one. Write this one next to that one where you're not canceling in your head. So make sure you practice the ones I've given you. Let me finish this one. This is, I'm going to multiply x plus 2 times x minus 3. That's going to give me x squared minus x minus 6. But I don't want to mess it up. It's behind this minus sign. Over here I have 5 times x squared minus x plus 6, minus 6. Sorry, I get so tired of this board that messes up. Over here, I have 5 times x squared minus x minus 6. So now I have 8x squared minus 4 minus 8x squared plus 8x plus 48 equals 5x squared minus 5x minus 30. I'm pretend like that said 30. That says 30 back there. Minus 30. Okay. Wow. Am I with the eraser? Okay. Oh, it's because it doesn't know where I am. It's not oriented over there. Let me guess. Minus 30. Okay.
There we go.
These 8x squareds cancel out. I don't like to have a negative x squared, so I'm going to move everything to this side. 5x squared. I'm going to subtract 8x, so that's going to give me negative 13x. That's going to give me 44. Am I getting the right answer? 44 and 30. I'm not getting what they got. They got 46. Oh, girls, look what I did wrong. That was 8x squared. I wrote minus 4. That should be minus 32 right
Happens to
there.
everyone.
And so anyway, you get 16 on this side when you're following your work. I'm sorry, I called my mistake. No, you get 46. All right, the whole reason I wanted to get this one done before class was over, and sorry I made that mistake, but you get 46. They factor it for you, and they get 2 answers, -2 and 23/5. The only answer here is 23/5 because way back up at the top,
Cause, yeah.
you couldn't use
yeah,
-2. Okay, so double check that.
Because of positive 2.
Because it would make.
Because it says x plus 2.
Yes.
Okay? All right, and then you have lots of practice, and the answers follow, is that correct?
Yes.
So lots of equations. I wouldn't even do all of these. I would do a few and check my answers and see if I'm doing okay. But you can do them all if you want, okay? This is, and I'll open up some Delta Math, and then you'll be fine, okay? This is plenty difficult. I wouldn't be anything harder on the test. Bye, run away.
Thank you.
All right. Scary teenager.